Let us now look into the salient features of collision theory, which comes under chemical kinetics. Collision theory explains why different reactions occur at different rates and suggests way to change the rate of the reaction. Collision theory states that for a chemical reaction to occur, the reacting molecules must collide with one another. So the rate of the reaction depends on the number of collisions or the frequency of collisions. The theory also tells us that all collisions need not result in product formation. Therefore, the two important conditions for effective collisions are to attain sufficient energy called the threshold energy, and the second condition being the proper orientation of the colliding molecules. Now, let us see the concept of successful and unsuccessful collisions or effective and ineffective collisions in this slide. The first picture shows the occurrence of unsuccessful collision, meaning when the two reactant molecules come and collide, they simply collide and go away without reacting. So there is no product formation or there is no chemical reaction occurring in this case. It's only a simple elastic collision that occurs between two reactant molecules. In the second picture, which says successful collision, the same reactant molecules, they come and collide and get converted into a new molecule or the product, as you could see from the color changes in the images. And when these two molecules, they collide, they exchange energy, and one molecule may lose energy and another may gain, or there could be a bond formation and bond breakage occurring in this step, resulting in the formation of products. And this is defined as a successful collision. And for a chemical reaction to occur with a high rate, we need as many successful collisions as possible. Now, in this slide, we are going to discuss the effective and ineffective collision with a typical chemical reaction. The reaction is between nitric oxide and ozone. In the first case, nitric oxide and ozone, they do collide, but then they don't result in the formation of a product, and after the collision, they go back as again nitric oxide and ozone. Therefore, we define this as an ineffective collision. So, no chemical reaction has occurred in this case. Now, in the second case, that is nitric oxide and ozone, they just collide and exchange energy, and we call it as an effective collision. And now the product is formed, NO2 and O2. And now, therefore, why in the first case there is no product formation in spite of collision? Why in the second case there is a product formation after collision? So this is with respect to the first condition, that the colliding molecules need to have a sufficient energy called threshold energy for the conversion into product. Now let us try to see elaborately these two conditions by taking a typical example. Consider a reaction between two homonuclear diatomic molecules, that is A2, a B2, two homonuclear diatomic molecules. They do react and form two AB molecules. Now, according to kinetic theory of gases, suppose if you assume that this is a gas phase reaction, the molecules A2 and B2 in the reaction vessel are randomly moving. Millions and millions of molecules are in random motion, and the occurrence of collisions is more. And now, these randomly moving and oriented molecules, they hit each other and they tend to collide. And during these collisions, there could be two possibilities, as I said earlier. One is an effective collision, another one is an ineffective collision. Now, those molecules which have the threshold energy, when they collide, then they tend to form the product. But then if the molecules with insufficient energy, they do collide, then it doesn't lead to a chemical reaction. Now we'll see a little elaborately the first condition, the requirement to attain a threshold energy. And now this picture explains the occurrence of ineffective collision. Assume we have two types of molecules in this gas phase. One type of molecule have very low energy and another type of molecules may have high energy. Meaning, among A2, there could be a few number of molecules with high energy. There could be a few number of molecules with low energy. Similarly, among B2 molecules. When a high energy A2 molecule collides with a low energy B2 molecule, then the collision does not result in the required threshold energy for the reaction to occur, and therefore it turns out to be an ineffective collision. This picture shows you the occurrence of effective collision. Now let us look into the second option. What happens if two high energy molecules collide with each other? For example, the high energy A2 molecule collides with the high energy B2 molecule, and then during the collision, they possess the required threshold energy and they try to interact with each other, meaning they tend to form a bond and a few bonds start breaking. Now let us move on to the second condition for collision to occur effectively, that is the orientation of the molecules, colliding molecules. First orientation shows that it is an improper orientation. For example, when A2 and B2 approach each other along the bond axis, then this may result in an improper interaction between the two A atoms of A2 molecule and the two B atoms of the B2 molecule. And therefore, it doesn't result in the product formation, and then it becomes an ineffective collision. Now we'll see the occurrence of proper orientation. Now the same A2 and B2 molecule, if they approach each other perpendicular to the bond in a direction perpendicular to the bond axis, then there is a lot of probability for the molecules to interact in an effective way, and this results in the product formation. So this can be defined as a proper orientation. Now we'll move on to the activated state concept in collision theory. So students, I think you would have understood the concept of collision theory and the conditions required for an effective collisions to occur in a reaction. So as I told you earlier, the two conditions, one is the threshold energy, second one is a proper orientation. Let us assume that a collision has occurred in such a way that the threshold energy is met with and also the proper orientation has occurred. Now, if the collision has become an effective collision, now A2 and B2, they react with each other to form a state, a high energy state called activated state. So this is an high energy state in between the reactant and the product state, and the existence of molecule in this state is called an activated complex. Now let me explain the formation of activated state through this picture. So as I told you, the A2 molecule and B2 molecule, they approach each other in the proper direction and they also have the sufficient energy. And now when they combine, they collide, our interaction between these two molecules happens in terms of energy exchange. And now the bond between two A molecules and 2B molecule gets weakened, and at the same time a new bond between A and B gets formed. So new bonds are formed and existing bonds are weakened. So this happens simultaneously, and therefore all the four atoms are connected to each other through a weak bond, and this structure is called the activated complex, and this is neither the structure of the reactant nor the structure of the product. and the molecule exists in such a state, this is called an activated state, and it is usually higher in energy compared to the reactants and products. What happens when the activated state is formed? Once the activated state is formed, and then the next step is immediately the existing bonds, they break completely and the new bonds are formed and the molecules turn out into products and the chemical reaction is complete. So now you see from the activated state, the product molecules AB are being formed. So therefore, the overall reaction has now occurred. A2, B2 react with each other to form two AB molecules. A chemical reaction has successfully occurred. The same reaction pathway can also be understood using an energy profile diagram. Now, these molecules on the left-hand side, that is the reactant molecules, they need to now satisfy the two conditions that we have seen elaborately, that is threshold energy and orientation. So they are now colliding randomly, and those collisions which are called successful collisions, they result in the formation of an activated state and then they roll down as the product. Now in the first case, you see that the A2 and B2 molecules are colliding with each other, but then the energy is not sufficient and therefore the molecules are rolling down again into the reactant state. So they are unable to reach the maximum energy, which is indicated as EA, which is actually the activation energy. This is what we mean by the threshold energy. So now this reaction doesn't occur because the molecules do not have the required energy to climb over the hill. Now in this slide, the orientation of the molecules is being highlighted through the energy profile diagram. So as I explained you earlier, A2 and B2, they approach in a very improper way and therefore they are unable to reach the peak of the energy profile diagram. So again they roll back down as the reactant and no product formation in this case. And now the third diagram shows you both the processes occur effectively. That is, the required energy is also met with the threshold energy, and also the orientation is proper, and therefore all the molecules that are colliding in the proper way, that is effective collisions, they reach the required energy and then they form the activated state. So the structure of the activated state is now being shown near the peak of the graph. And now once the activated state is formed, it just rolls down as the product. And now two AB molecules are formed on the right-hand side of the diagram. Now this reaction, we have indicated that the reactants are in the higher energy state compared to the products. So therefore, after the reaction is over, a difference of energy indicated by delta H is being released from the chemical system, and therefore this is defined as an exothermic reaction. There is also the possibility that the reactants can be lower in energy and products can be higher in energy, which will then lead to an endothermic reaction, which we will see detailed way in the next module, which talks about activation energy. So now to sum up, we have seen the significance of collision theory in the concept of chemical kinetics, and the two important conditions for effective collisions, that is threshold energy and the proper orientation of the molecules. And then when effective collisions occur, the reactants are not directly converted into product. They first land up in a high energy state called activated state, and this activated state then gets converted to product. And the structure of the activated state is neither the reactant structure nor the product structure. It is a combination of both, in which new bonds are formed at the expense of the existing bonds. Then effective collision has led into a product formation and a chemical reaction has occurred. And now, as I told you in the beginning, there are millions and millions of molecules in the reaction vessel, and It's all the probability of the collision. So how many collisions are effective collisions, and therefore they get converted into the product. So now you understand that why the rate of the reaction depends upon the number of collisions or the frequency of effective collisions. Higher the effective collision, higher the rate of product formation, and therefore in general we say the rate of the reaction increases. Thank you.